have to look at how to convert those binary conversions. Okay. And also multicast MAC addresses or MAC addresses that are used to communicate to a group of devices. So like I said, multicast is basically for devices within a group, and for the IP address side we're going to talk about that later. But for multicast address, they begin with FF0. So you can have FF01, FF02, FF05, FF08, 06. So it depends on here. So the FF, any MAC address that has, or any address that has the first 8 bits set to 1 and a 000, it is a multicast address. Whether it's an IP version 6 multicast address or it's a multicast address for MAC addresses to communicate in a group. So the multicast IP address that is required, corresponding multicast MAC addresses that begins with 01005E in hexadecimal. So it's very, very important that you remember the multicast IP address that requires a corresponding multicast MAC address. So this address 01005E, you may be asked in your exam to remember that. So guys, we go next to the LAN switch. The switch is a device that operates at the layer 2, but we have two versions of switches. We have switches that operate at layer 2 specifically, and we have other switches that operate both at layer 2 and layer 3, and they are called multi-layer switches. They are multi-layer switches, or you can call them hybrid switches, because they operate both layers of layer 2 and layer 3. They understand IP and they understand MAC addresses. They understand frames and understand packets. They can forward frames and forward packets at the same time. So those are the switches. But right now we're talking about switch, so we're talking about layer 2 switch that only understand frames, that only understand MAC address, and they operate only at layer 2. So they make forwarding decisions based on layer 2 address only, like I said, MAC address. So switches, layer 2 switches only do not understand IP address. If they will have to communicate using IP, they will need a protocol called ARP to translate those IP addresses to their MAC addresses, so they can be able to forward a packet. So MAC address table, as it is not launched, the MAC address for the 4 attached PC. So what they're suggesting here is that the first time that you have a switch, a layer 2 switch, it does not have any MAC addresses launched. So we'll have to explain the difference between switch, hop, and the route. Switch and hop, they all do network access. They provide network access. But the difference between hop and a switch is that the switch has a mechanism that it can build a MAC address table. That MAC address table is what the switch will use to remember if it knows about a particular device that is connected to it directly. So that is what the switch does. So that's why you have that MAC address table here. The MAC address table, for instance, is that I am a security guard. I'll be sitting out there at the gate, and any person that comes, I take your ID card and then give you a visitor's card. So if something happens, I can be able to go back to if anybody comes and say, I am looking for visitors, so maybe let's say a hospital, you come and say, I am looking for patients, so and so, they are able to spot the patient because they have a record of who is in and who is out, at what ward or what hospital room that they will be in. It's very important that you know that that's how switches behave. Let's say, for instance, this PC right here is connected, PC A, B, C, they're all connected to the switch. The first time that they did not forward any packet or any frame, toward or across this switch MAC address table will completely empty, because no packet or no frames are forwarded or received from the switch. So if, for instance, this PC A with a MAC address of 000A that wants to forward packet or a frame to a device here, PC D, the case is that PCA is first going to broadcast that frame. It will broadcast that frame to port 2, 3, and 4. All ports here will receive this frame, but port 2, port 3 would all ignore, that is PCB and C would ignore this frame because it is not destined for them, but PCD would respond. So this broadcast that is sent, or this floating that is sent, all these port 2, 3, 4 would receive except port 1, which is the originating port or the ingress port. So all other egress ports here, right here, would receive this frame, and those that are not destined for this particular frame will drop or ignore it, and then the recipient device would respond. So in that case, at the first go, the switch here does not know about PCA, but because PCA tried to send a frame across the switch, Then the switch first, what it will do is it will say, wait, I have to know about you first. I have to know about you. So it will take note of that PCA's MAC address and the port that it is connected, for instance, port 1. And then it will float this frame to all the ports 2, 3, 4 at the same time. And then port 2, 3, 4 will all receive this frame, and then they will tend to ignore 2 and 3 will ignore, that is PC B and C would ignore. And if PC D is response or is the intended recipient, it will respond back to PC A. At that point, the switch will take note of PC D's port 4, and the next time that PC A wants to communicate to PC D, it will just do a sort of a unicast. That is because now the switch learn about these two devices. I hope this is briefly explained. So that is just the explanation right there. I will not need to go through all those reading. I've just explained it all. So yeah, that's all it. So the switch will build MAC address table based on those information. So the switch MAC address information will include the data and the frame text sequence, which is important. So that's a video demonstration, and I'll go to my next slide. So we talk about switch forwarding method. A switch will do forwarding method based on two options. We have the store and forward method and the cut through method. The difference is that with the store and forward, it is to provide a lot of latency, that is a lot of delay, but it's the best because it makes sure that all frames that are received are sent successfully to their destination, because it makes sure that it buffer the entire frame, make sure that it receives the entire frame, run FCS frame text sequence to make sure that the frames are error free, and then we'll have it forwarded to the destination device. So it will also use CRC, the cycle redundancy check, to see if the frames are entirely free from errors. So that's why store and forward is good, but it provides a lot of latency. And cut through is another method, but this method is a very fast method of transmit. Let's say, for instance, our video streamings, live football games and stuff like that, we can say they use this cut through. With this, they make sure that they use a just minimum. They just have to make sure that they understand where the frame is going, identify where the frame is going, and they will download just few seconds or milliseconds of data, and then it will go. So as it comes, it goes. As it comes, so data will not be tested to see if it is correct. That is, if you're watching your football and then you have a scrambled channel, you lost that those moments that will pass by whilst your channel is scrambled. So that is what this cut through is. But if you watch the video and you, for instance, you go to YouTube and download everything, that is store and forward. So that's just a simplified scenario that I downloaded everything on my device from YouTube. I'm watching it. That is different. If there are any errors or anything, you would know. But this one, there can be errors, and then the errors will not be corrected because it is on the go. So that's what cut through method is. So guys, so in cut through switching, the switch buffers just enough of frame, like I explained, to read the destination, so it can determine which port. So there are two variations or variants or different types of cut through switching. We have fast forward switching, and we have fragment free. With the fast forward, it always lowest level of latency. You may be asked in an exam which of the forwarding methods provide the lowest level of latency. It is talking about fast forward switching. The switch will immediately forward a packet after reading the destination address. But we have another option called the fragment free, in which the switch will store the first 64 bytes of the frame before it will forward those frames. So it's important that you remember those ones. So we have memory buffering options. We have two memories buffering methods with switches. We have port-based memory and we have shared-based. With the shared-based, it is good because all frames are deposited into a common buffer which is shared by all ports in the switch. With the port-based, the frames are stored in queues and they are linked to specific incoming and outgoing ports. A frame is transmitted when all the frames ahead of it have been transmitted, which provide a lot of latency. So guys, like I was explaining about these duplexes before. Duplex is the mode of communication. Like I said yesterday, we have three modes of duplex. We have full duplex, bidirectional, half duplex, one way or directional, and we have single duplex, that is one way only. We talk about this one. So I said full duplex, like phone communication between two people. Half duplex, like using WhatsApp voice messages, or you can use walkie-talkie as an example. And the single duplex is like using radio to listen to broadcast information. So we have if you're connecting two switches, in order for them to communicate, they must match in terms of duplex settings. So if you set this switch at full duplex and you connect a hop, for instance, as hop here, this is a switch and you connect a hop here, because a hop runs at half duplex, it will not be able to communicate with this switch. So you have to make this switch at a half duplex, and so that it can connect. So otherwise, the best to video on the server side, make sure that your switch duplex settings are set to automatic, so that any device at any speed or duplex will have to match with that. So speed and duplex settings, I would advise you to always set them at auto, so that you provide safety. We have another one here as the Auto MDIX. Auto MDIX is a process or a way or a technology that help networkers to use available, not the preferred. Okay, they use the available cable to connect your device. Let's say, for instance, I am connecting two switches right here. According to my video, if you watch, two devices that are alike, they use what? Crossover. And here you can see I am using a straight cable. That means I'm using straight through between my two switches right here. This is not the appropriate cable right here for these switches. So in order for these two switches to communicate, I will use what we call Auto MDIX configuration. So my switches will internally or logically configure this cable as a cable that they require, that is the crossover. So they're logically going to create their own crossover between them using the straight through communication cable that's between them. So we're going to talk about this address resolution protocol. What it does is that it resolves IP addresses to MAC address and MAC address to IP addresses. That is, if a device from a LAN, because switches do not understand about IP address, or a PC from the network is requesting to communicate and it pinged an IP address. Because switches do not understand IP address, the switch will have to interpret that IP address to what device is using that particular IP address to know the MAC address of that switch or of that device that is on its LAN, so it can forward the packet. So the protocol that helps this switch to be able to do that, to match which IP address is assigned to what IP address, MAC address to IP address resolution, it uses the ARP. So I'm going to make a video about that just to explain this switch behavior. After I will give you how to convert from hexadecimal to binary. So when the destination IP address is on a remote network, that's a different thing. The switch will have to forward the packet to a gateway. A gateway is a device that connects those devices to outside network or outside of the LAN, which most of the time is a router. So we're going to do that one quickly. So when a device sends an Ethernet frame, it contains those two addresses, that is the destination IP, a MAC address, and the source MAC address. To determine the destination MAC address, the device will use the ARP, that's the address resolution protocol, to resolve what IP address to what MAC address. So what it does is that it checks on the ARP table of the ARP cache of the switch to know the MAC address assigned to a particular IP address. So that protocol helps the switch to identify IP to MAC address. So that's just it, guys, and that is the video demonstration. If you have any questions for us, you can ask. So you can check your ARP table configuration for your switch by using show ARP, or you can check your PC's ARP configuration by using ARP-A, and that will give you your switch, your PC's ARP settings. And if you want to check your ARP address resolution processes on your PC or on your switch or your router, you can use the show IP ARP command. That is a very good command, guys, and I'll see you guys in my next video. We're going to talk about ARP in my next video so well, so you guys will understand even about this ARP spoofing and so on and so forth. So that is a switch attack and a security vulnerability, and we're going to talk about it in my next video, which is going to be my full picture or my full video on board. Okay, guys, so I see you in my next video.